From here on out, every lesson is an 8th grade lesson. Today's topic is understanding exponents. This is level 13, stage 1, 8th grade math. Let's take a look at the vocabulary for stage 1. What does it mean to square a number? What is a perfect square? What is exponential form? What is expanded form? What is standard form? To square means to multiply a number by itself. So for example, 4 squared means 4 times 4. A perfect square is the result of 2 whole numbers being multiplied together. So like 3 times 3 is 9. You could say that 9 is a perfect square. Exponential form is a number written with a base and an exponent. For example, 4 to the second power. Expanded form shows the same thing, but using multiplication. For example, 4 times 4. And standard form is the numerical value of the expression. For example, the number 16. Here are some fast facts about exponents. Any non-zero base with an exponent of 0 is worth 1. For example, 35 to the 0 power is worth 1, and 6 to the 0 power is worth 1. That's because any number divided by itself is worth 1. That's why. Any exponent with a base of 0 is worth 0. For example, 0 to the 7th power is 0, and 0 to the 2nd power is 0. Any non-zero base with an exponent of 1 is worth the same as the base. So 9 to the 1st power is worth 9, and 6 to the 1st power is worth 6. Any exponent with a base of 10 will always start with the number 1 followed by zeros. For example, 10 to the 3rd power is the number 1 with 3 zeros, and 10 to the 8th power is the number 1 with 8 zeros. It's kind of easy. Example number 1. Write this expression in exponential form. 5 times 5 times 5 times 5. Currently, it's an expanded form. Since there are 4 5s, the answer is 5 to the 4th power. They didn't ask us to solve it, so we're just going to leave it just like that. Easy peasy. Example number 2. Write this expression in exponential form. 5 times 5 times 5 times 5 times 2 times 2 times 2. Since there are 4 5s and 3 2s, the answer is 2 to the 3rd power times 5 to the 4th power. Once again, you don't need to solve it and put it into standard form if they don't ask you to. 2 thumbs up. Example number 3. Write this expression in exponential form. 5 times 5 times 5 times 5 times d times d. We don't know what the value of d is, but we can combine the 5's together to call it 5 to the 4th power. We can combine the d's together to call it d to the 2nd power. The answer is 5 to the 4th power times d to the 2nd power. It's always best to put your constants before your variables. Yes! Example number 4. Write this expression in exponential form. A times B times A times C times B times A. I don't know how much each letter is worth, but I do know that I can group them together. Since there are 3 letter A's, we're going to call it A to the 3rd. There's 2 letter B's, we're going to call that B to the 2nd power, and there's just 1 letter C. So we would say times C, or you could say times C to the 1st power. Either way would be fine. Hot diggity! Here are some perfect squares I would like you to memorize. 1 to the second power is 1, 2 to the second power is 4, 3 to the second power is 9, 4 to the second power is 16, 5 to the second power is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81, and 10 times 10 is 100. You should already know those because they appear on your times table right here in the center. A couple more that I'll have on the next page is going to be 11 times 11 and 12 times 12. Some more perfect squares. 11 times 11 is 121. 12 times 12 is 144. 13 times 13 is 169. 14 times 14 has the same three digits, the 1, the 6, and the 9, but you switch those to make it 196. 15 times 15 is 225. 16 times 16 is 256. 17 times 17 is 289. 18 times 18 is 324. 19 times 19 is 361. And 20 times 20 is 400. Once again, I encourage you guys to memorize these, put them on flashcards, remember them, and it'll make math a whole lot easier in 8th grade. Example number 5. Write this expression in standard form using numbers. The exponential form is 5 to the third power. The expanded form is 5 times 5 times 5. And in standard form, we would call that 125. High five! Example number 6. Write this expression in standard form. In exponential form, it's 3 to the 4th power. In expanded form, that would mean 3 times 3 times 3 times 3. By the way, the answer is not 12. The answer is 81. That's all you got to do. Example number 7. Write this expression in standard form. -5 to the second power. In expanded form, that would be -5 times -5. Well, a negative times a negative is a positive, which makes our answer positive 25. Good job. Example number 8, our final example. Write this expression in standard form. -5 to the second power. That means -1, the negative, times 5 times 5. The answer is -25. Now, before you go thinking that a negative times a negative is a positive, remember, it's only the 5 that had the exponent, not the negative sign. No pressure. Bzzz, be careful. A common mistake that students make when evaluating expressions is they think -4 to the second power is equal -4 to the second power, but it's not. Be sure to remember to use PEMDAS, and that's because exponents come before multiplication. So while -4 in parentheses to the second power is worth 16, -4 without the parentheses is worth a -16. And finally, our motivational quote of the day: everybody wants happiness and nobody wants pain, but you can't have a rainbow without a little bit of rain. I like that quote because it makes you think that there's something positive even on a bad day. Even on those days that you just want to get rid of, there's something positive that can be taken away from it, and that's the rainbow that takes place when it's raining outside. So I encourage you guys to always look for the positive even when something negative is happening. Well, that's the end of today's video. Hopefully you learned something new about exponents. Please join us in our next video as we learn about square roots. We'll see you then. See ya!